what I'm going to share with you is based on the case studies for the past decade, and hopefully you'll get to see that what we said in as early as 1990s as part of the first IPCC assessment is consistent with these cases that we are observing. But there is a limit to what we can really say, a limit to what we can attribute these extreme events to. So I will highlight those and share with you, and I will be happy to answer any questions that you may have. We have produced a summary. We were trying to put it on our website, and we were having some technical difficulties, and hopefully we'll be able to make some print copies for you so that you can take with you. Every one of these symbols that you see on this screen, can we go to the full screen mode? This is not, yeah. And there is a color designation associated with each one of these events. Each of these symbols and color designations indicate what extreme events we are talking about. And as I stated, these are the cases that we have observed over the past decade. And their frequency, the return time, there is a sort of an upward trend in those as well. And most of these were assessed and projected as part of the first IPCC assessment as early as 1990. I read to you a very short excerpt from the 1990, the very first assessment by IPCC that stated the episodes of high temperatures would most likely become more frequent in the future, and cold episodes less frequent. If we go to the next slide, please. If we go to the next slide, the one after this. Yeah, okay. So here is the heat wave of 2003 on the left-hand side, and the latest heat wave that we observed over Russia in 2010. The curve at the bottom with the blue sort of lines indicates the frequency and distribution of all other heat waves prior to 2003. You see the red line on the right-hand side, the heat wave that prevailed over Europe in 2003, and it's a class of its own. Nothing comparable to what we had observed before that. The one on the right over Russia, according to the Russian Federation, they had not observed anything like it since 1500. So basically, these events that are very large in magnitude are sort of different from what we have observed in the past, which again supports the statement by the IPCC first assessment and subsequent one that the frequency, magnitude, and the extent of these events are going to be different from what we have seen in the past. The number of heat waves has increased based on the observations in the past, and they have become more widespread, and the number of warm nights increasing, the number of cold nights is decreasing, the number of warm days are increasing, the number of cold days are decreasing. So again, the trend is toward warmer, and this warmth also manifests itself in form of drying the soil, evaporating the water from the soil, and creating more droughts in the interior of the continents. So there is a connection in that regard, that the warmer temperature also will lead to some drought in the interior of the continents. So the next slide, if I may have the next one, again, please continue. And again, you will see that the record temperatures on the right-hand side at the bottom of the right frame indicates all the temperature records that Russia Federation has had on the record, and the last sort of red histogram shows you the magnitude of the temperature observed over Russia. It is significantly higher than what we had observed since 1500, so 1900 earlier in the century. So if you move on to the next slide. Now, there has been some more extensive research on the heat wave over Europe. And if we superimpose what we observed in 2003 on the projected temperature increases by the IPCC for the rest of this century, what is really most revealing that as warm as it was 2003 is going to be the coldest that we may observe for the rest of the century. So the trend that we see in terms of the temperature increase is going to be significantly higher than even these extreme events, which basically means that these extreme events in magnitude are going to be greater into the future, and they're warmer atmosphere. Please, the next slide. The next example pertains to the frequency of the tropical storms and hurricanes. Again, the fourth assessment indicated that there will be a tendency toward more frequent, larger in magnitude tropical cyclones and hurricanes. So what we have done in this study, the authors went back and looked at all the projections that we have for the rest of the century, for the next 100 years, and tried to use lower sort of categories, like category 1 to 3 hurricanes is going to be decreasing. However, the number of hurricanes or tropical storms in the category of 4 and 5 that are more intense are going to increase. So the red histogram on the right-hand side shows the frequency of sort of stronger hurricanes in the projected models for the rest of the century. The blue and yellow are in the category 1 to 3 hurricanes. So once again, the projections indicate that under a warmer climate, we will see more frequent, higher intensity hurricanes and tropical storms. The next slide, because that's really the type of the examples that I have prepared for you. Let me just conclude by saying a few words in terms of what we know and what we don't know. Observed extreme events from the past decade are significantly different in magnitude and duration as compared with the historical records. These cases will be studied in detail. We will understand the underlying processes, what contributes to the formation of these events, and we will represent those processes in our models, which help us project the future events more realistically. So in short, we are learning from these events as we look into the future. We cannot basically currently quantify or attribute with great certainty the influence of climate warming on extreme events. However, it is likely that in a warmer climate, the magnitude, frequency, and duration of these events will be different from what we have observed in the past. Once again, I hope it's clear that these cases more or less support that statement. It is naturally prudent to consider the best available information. At the moment, our knowledge is not complete, and frankly, this is an area of research that our knowledge will continue to improve in the future. So we really have to take advantage of the best knowledge that we have available to us as we plan for the national, regional, and global infrastructure in order to minimize the adverse impact of these events on the natural resources, on life and property. So that's really the mission of the WMO, and we will talk about the Global Framework for Climate Services. One of the services that this framework is promising to provide to the most vulnerable nations is provision of this type of information routinely for different regions around the globe. I said it very clearly in my last statement that we must consider what we know today in our planning for the future in order to minimize the adverse impact of these events on life, property, and way of life into the future. That was really my conclusion.